Hello, teacher. Hello, students. Welcome to today's lesson on organic chemistry. In our previous lesson, we discussed the preparation of alcohols. We focused on ethanol and demonstrated how it is extracted through fermentation of sugar in a laboratory. Today, we will learn about the chemical properties of alcohols. We will identify some of the possible chemical reactions of alcohols, such as oxidation. We will also discuss the properties of aldehydes and ketones. If you are ready, we will begin. The oxidation products of alcohols depend on the type of alcohol and the nature of the oxidizing agents. However, this type of reaction is vital to the production of useful oxygen derivatives of hydrocarbons such as aldehydes, ketones, and carboxylic acids. If a primary alcohol is oxidized in the presence of mild oxidizing agents, an aldehyde is produced. Here is the general equation for this type of reaction. In this case, the primary alcohol is oxidized in the presence of copper at 360 degrees Celsius to produce an aldehyde. Ethanol can be oxidized in this way to produce ethanal. Notice the structure of the ethanal compound and how this reflects the structure indicated in the general reaction. When oxidized in the presence of strong oxidizing agents, a primary alcohol will still produce an aldehyde. However, it will also continue reacting to become carboxylic acid. The general formula for this type of reaction is shown here. We can see that the primary alcohol is being oxidized to acidified potassium permanganate to produce an aldehyde. Then the aldehyde is further oxidized by the acidified compound to produce carboxylic acid. If this practice is applied to ethanol, it is initially oxidized by the acidified potassium permanganate to produce ethanal, which in turn is oxidized to become ethanoic acid. Aldehydes are represented by the general structural formula you see here. They can also be expressed as RCHO. R, in this case, represents the alkyl group R equals H in case of the first member of aldehyde series. In the nomenclature of aldehydes, we use the suffix -al instead of the suffix -e in the corresponding alkane name. This suffix is an indicator of the functional group CHO. Here is a list of some of the lowest members in the aldehyde group. Notice that each compound has replaced the E suffix of alkanes with the al suffix of aldehydes. Students, let us do an activity to review the oxidation of primary alcohols before we continue on to secondary alcohols. Here is a list of questions to be answered. You may begin.
Students, let's get ready. Begin. Time's up. Let's get back to our lesson.
Welcome back, students. If you have been following along until now, this should have been an easy activity. Let us now answer the questions together. When an alcohol is oxidized with acidified potassium permanganate, the end product is carboxylic acid. This is a strong agent. Therefore, the compound changes to an aldehyde first and then a further reaction generates the carboxylic acid. The general structural formula of an aldehyde is RCHO. You may have chosen to present this formula using the complete structural layout, which appears as you see it here. As the second question will show, the functional group of aldehydes is CHO. Compounds possessing this functional group always finish with the suffix -al. Did you answer all the questions correctly? If so, great job, everyone. Secondary alcohols can also undergo oxidation reactions. When they are reacted this way, the product is a ketone. The general oxidation reaction formula for alcohols appears as you see it here. Notice that the structure of ketones is slightly different than aldehydes. The general structural formula of ketones is RCOR prime, where R and R prime can either be the same hydrocarbon group or different. This is also represented in the formula you see here. When ketones are named, the suffix E that is standard to alkanes is replaced by the suffix -one, which indicates the functional group. However, unlike aldehydes, the position of the functional group must be indicated in the name of higher ketones. Therefore, the longest chain containing the functional group is chosen as the parent structure. Then, the carbon atoms on the chain are numbered starting from the carbon atom closest to the carbonyl group. Tertiary alcohols and ketones highly resist oxidation. Under a set of carefully constructed circumstances, tertiary alcohols and ketones can be oxidized to produce a mixture of carboxylic acids. These reactions present examples of both compounds producing carboxylic acids. Students, let us do one more activity. Identify the following structures as aldehydes or ketones. You may begin.
Students, let's get ready. Begin. Let's get back to our lesson.
Welcome back, students. Let us now identify the structures to see if your answers are correct. The first structure is propanone, which is a ketone. The second structure is ethanal, which is an aldehyde. The third structure is propanal, which is an aldehyde. The last structure is 3-pentanone, which is a ketone. If these were your answers, excellent job. That is all the time we have for today, students. We have discussed the chemical reactions of alcohols, focusing on the oxidation of primary, secondary, and tertiary alcohols. We have also learned about the formation of aldehydes and ketones. Until next time, thank you, teacher. Thank you, students.